Alrighty, let's see what we got here. So I didn't actually manage to come up with the answer yesterday to the hard, which is sad because I had previously solved it. Thought about it some more, but I couldn't come up with anything. Also, this seems almost trollish that this is a medium with something that looks very similar to yesterday. Anyways, container with most water. You're given an integer array height of length n. There are n vertical lines drawn such that the endpoints of the ith line is I of 0, I comma 0, and I comma height. Okay, so it's just, I'm not sure why they set it up this way. It's just a bunch of heights. Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water the container can store. Okay. So I see. So you're trying to find two high lines that contain the biggest rectangle. Interesting. Do 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 do. This is a monotonic decreasing stack. So if you keep a monotonic decreasing stack, then you keep track of this thing, this thing, this thing, this thing. Because each time you see a height, the maximum area that you can get would be that height times the earliest thing that's bigger than it. Or should you have a monotonic increasing stack? So monotonic increasing stack, it'd be keep track of this, and then this. I guess you might want a monotonic increasing. Just doesn't feel right. Monotonic increasing stack. So you keep track of this, this gets popped, and then this is put on. Then this gets popped and this gets put on. So you have this and this. Yeah, it should be monotonic decreasing stack. So you keep track of this, then this, and this, and this. This thing might pop everything. I guess this thing would pop this stuff. And you put on this. This thing doesn't pop. This thing doesn't pop. But then if this thing was really high, right, then technically this thing would pop this thing off the stack. And therefore, when this thing gets put on the stack, you don't know how far back it goes. Let me think. The biggest area, if you just add in another height, you would need to compare the previous maximum height So if you had an 8 and then a 9, if you had a height that was 8 and the height then was 7, you would never care about having a height that's 7, because anything that would extend to the 7 would extend to the 8. So, okay, so you don't need a monotonic increasing. So if you had a monotonic, or you don't want to keep the decreasing values, because that's just never going to be used. You just would use a higher value here. So if you kept track of a monotonic increasing stack, like this one, then this one, this thing just doesn't pop anything. And then if this one was taller, then keep track of that. Is that even monotonic increasing? Yeah, it is monotonic increasing. Keep track of this one, then this one, then maybe this was 10, keep track of that. But then if you had an 8 here, 8 technically extend to this thing rather than to the 10. How would you know how far it extends back? 1, 8, 10. One to 8 to 10. Is there a certain height that it's not useful to keep track of? So if you go from 8 to, let's say, 9, then that means that in order for the 8 to be better than the 9, so if my heights were 1, 8, 9, 8, then if 8 extends to the 8, that's 16. 8 extends to the 9, that's 8. This was 9. The 9 can extend to the 8, and that's 16. 9 can extend to the 9, that's 9. But if there was, let's say, a few number between, then it could be like 8 extends to the 9 and get like 8 times, I don't know, x amount versus 9 times x minus 1. And if I can compare the two, and this is 8x compared to 9x minus 9. So that's 9 is compared to 9 to x. So if the length of it is longer than 9 apart, then the 9 is better. And if the length is shorter than 9 apart, then the 8 is better. 189. Some number than 9. But if it's like 8, right? Then the 8 can extend to the 8, or the 8 can extend to the 9. The 8 would need to extend to the 8. Let's say this was a 7. Then the 8 would extend to the 7 and get 7 times that. 7 times that. 7 times 8, or 7 times however far apart they are. I feel like this should be linear. It's 10 to the 5th. It could be n log n. It's definitely not n squared in terms of. So the other option, or the other idea, might be doing a binary search in some fashion. Like I can do a guess what the maximum height is. Guess what the maximum height is. Let's see, if I do a monotonic increasing, I do a monotonic increasing. One, 8, 10, 1, 7, 9. You see another 8 later on. Technically, that 8 should get rid of this 9. If it was maintaining it. But it definitely shouldn't. So this 8 just needs to check whether or not there's a maximum somewhere here. This 8 needs to check within the maintain monotonic increasing stack. Whatever the biggest, it would be 8 times well, in theory it could be 8 extends to 1 if this was like a million things between the 1 and the 7, like 1's all the way down. So in theory the 8 could extend to the 1 or the 7 or the 9. So it maintains monotonic increasing. You can do 2 monotonic stacks, one from the front side, one from the back side. And if I maintain a if I can maintain I'm just not doing this correctly. So I'm just not thinking about this correctly. If I just emptied out the water, so I start with this height, go to this height, highest should be 1, then I go to this height, the highest should be either 2 or 8, or 2 or 6, so it's the 6, and then I go to this height. I should be able to ignore this thing. This thing shouldn't matter. So this thing should be 2 to extend to here, so it's 4, or 2 extends to here, that's 3. So this thing can make a 4 or 3 versus the 6 that's the current high. So it keeps the 6. This is ignored. This thing can extend to here, and it makes 15, or extends to here, and it makes 4. I wonder. I mean, is it ever possible that this thing is the thing that you want to extend to versus this thing? I don't think so, right? Because you get one more base. I guess the only thing where it's possible is if this is another one down the line here. So this extra height doesn't matter, and you just get one more base. Otherwise, if it's anything that's not 1, that's a height down here, then you just want to extend it to the 8 rather than 1. So anyways, this thing goes here, and it's 15, 5 times 3, and that's going to be the new high, 15. And this thing is 4 times 4, and that's 16. And then this thing is 8 times 5, and that's 40. 3 times 6, and that's 18. 7 times 7, that's 49. Notice you may not slant the container. Ooh la la. For each additional height, is there a quick way to determine the longest area base of that height? So I mean, this thing could, if I maintain the monotonic increasing, I maintain the monotonic increasing. Ten to the fifth. This thing, then this thing, then something higher. One, 2, 8, 3, 6, 4, 2, 5, 5, 6, 4, 7, 8, 8, 3, 9, 7. Okay. 1. Okay, what's going on? What is going on? So if I kept track of 1, 1, 8, 2, when I see the 6, I go through 8, and then go down to 1, and then I see the 2, I go to this 8, and I go to the 1. 5, go to the 8, then the 1. The 1 just never matters. But what if it was like 820? So there's like a bunch of stuff between the 1 and the 8. Bunch of 1s or 0s, something like that. So the 6 would go to the 8 and get 6, or the 6 could go to the 1 and get 20, 20. And because the 6 can go to the 1 and get something higher, then it keeps the 1. But if it can't go to the 1 and get something higher, then maybe it discards it. Right? Like why would you ever keep something that's further back that cannot possibly be used? Okay, so you have a monotonic increasing stack of heights that you're using, and you keep them the earliest one as long as you can find that that is the maximum. If it's ever not the maximum, then you go to the next one. So it's more like a monotonic queue. I guess you would remove from the front end. And then you would not remove maybe it's a monotonic queue. Just doesn't, I don't recall ever doing this before, even if I solved this. So that's probably not the answer, but monotonic, increasing Q. Okay, so let's say I'm going to have a deck, and then for every height in the array of heights, I think I need the index. This should be plural. The height is the height at index. And then I would pop. Do I pop here? So if the height is bigger, then I just add it to the stack, I want to say. If the height is bigger, add it to the stack. Or do I do a comparison first and then add to the stack? Or add to the queue? I think I do the comparison first. Compare with everything in the queue from the front onwards. So I think I need to have an original answer here. So it needs to be something like while there is a mono thing and the front of the mono thing while there is a mono thing, so this is 1, then 8, 1 gets added to the queue, then you see an 8, 8 would get added to the queue, then you see a 6, 6 would compare with the 1, and then 6 would be compared with the 8. Six would get compared with the 1, and the 6 would get compared with the 8. Okay. 6 would get compared with the 1. I think I need to do something where I compare. So if the mono stack needs to have 2 length. Length of the monotonic stack is greater than 1, and the height of the tank from this height to the first compared to the height of this tank to the second is better. And so I think it should be minimum min of this height and the height of the stack, which is going to be a tuple. That height times the width being the difference in indices. This index minus index at the top of the queue. So this thing is a deck where tuples has a height and index. And this thing is, I want to say greater than, or less than, actually, less than how this would go with the second H mono 1 0 times index minus mono 0, no, mono 1 1. That's the base. While that's the case, then pop left, pop the top of the queue, pop the front of the queue, mono, pop left. So if it's better to pop the top of the queue, then keep on popping. At that point, it should be maximal to use the tops. Answer equals max of answer, and the top being min height mono 0 0 times the width of the base is going to be index minus mono 0 1, and then lastly I add this tuple if this tuple would maintain increasing monostack. Mono dot append if this height is greater than the last in the queue's height, mono append tuple this height and this index. Return answer. Oh, I see. This only occurs if there is something. If mono. Okay, whoops. This also needs to have mono. If there is a stack, then answer is equal to this. If there is not anything in the mono, or if there is something in mono where this is height bigger than append. Okay, case 60, case 57 out of 65. 1, 2, 3, and 100, 1009. So, I see. Yeah. 9 goes to 1 and gets you 1. No. So the monotonic stack at that point. So 1, 2 gets added onto the stack. 3 can go to 1 or 3 can go to 2. It's going to be equivalent. So it maintains that. 1000 can go to 1, which is going to be, gives you 1, 2, 3. 1000 go to 2 gives you 4, so it pops out 1. 1000 can go to 3, that gives you 3. So it maintains 2, 3, 100. 9 can go to 2, and that gives you 6. 9 can go to 3, and that gives you 6. Theory 9 can go to 1000, that gives you 9. because it's 6 and 6, you don't pop. Because it's 6 and 6, you don't pop. You never check that 1000 goes to 9. Interesting. Do 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 do. I mean, I guess you could do. What should you do here? What should you do here? Maintain the 2, 1, the 2, the 3. Maintain the 1, the 2, the 3. Do 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 do. One, 2, 3009. One. Description. Pretty sure you just shouldn't be maintaining a monotonic decreasing rate. Like you shouldn't be. One and all the way to 8. This doesn't make sense to do monotonic decreasing, so it should be a monotonic increasing. Then how do you make use of that information to cross-check for the heights that were smaller than the last? I mean, I guess you could do a search. You can do a bisect within your monotonic stack where the height would be found. So that would be like n log n, really? It's not linear, but it's not terrible. I mean, if this was linear, then you might expect this to be 10 to like 6 rather than 10 to the 5th. Okay, maybe it is a search, like you're searching for the height. that best can be used earliest. The earliest height that is bigger than it. Actually, does that guarantee it? I don't know if it does. So if I search 9 within like a monotonic increasing stack, then does that guarantee that what I find is how far it should extend back to? Not really, because if there's like a million ones, so your stack is like 1, but there's a hidden million there. 2, 3, 1,009. 9, you search for 9 within that. You find it here and you just try to extend the 9 to 3 and the 9 to 1,000, but you don't actually try to send 9 to 1. Whereas the 1 is actually how far the 9 should extend to. Oof. Man. Slow and steady decline of mental capability. Eight, 6, 2. I feel like there's some simple, elegant solution that I'm missing. 8, 6, 2. Five, pop the 2. 4. Another 8. What if I had a monotonic increase and a monotonic decreasing? If I kept both. If I kept a monotonic decreasing, if I kept a monotonic increasing, the heights there should be my left side heights. Because, yeah, okay. Monotonic increasing is guaranteed to contain the left side of my tank. Because anything that is not in there would be strictly worse than something that is in there. So I'm going to make this note here. If maintain a monotonic increasing stack of heights, the tank, the left side of max tank must be a height in that stack. So by logic, if I maintain similarly, if I maintain a monotonic decreasing stack. The right side of the max tank must be a height in that stack. I think. Yeah, I'm pretty sure that's right. So this thing goes up, this thing has to be it, and then if I maintain it going down, this thing has to be it. And then how would I compare the two? How would I compare the two? Like, how would I generate the maximum areas based on those stacks? It could be an n-squared operation where I do, well, n-squared is the worst case operation where I compare this, every possible stack in the first versus every possible height in the first stack against every possible height in the n stack. Somehow use like a two-pointer deal. Two-pointer deal. So if my heights in the first stack were, let's say, 1, 3, 4, 5, 10, and then my heights in the other stack were 20, 8, 3, 2, 1. And let's say this is like 1 at 1, 3 at 2, 4, 3, 5, 4, 10, say 10, 10. And then the other one, this is like 20, let's say this is 15, 8, 17, 3, 18, 2, 19, 120. Those are the x coordinate of those heights. So I do 1 to 20 and get like 19. Then the next comparison would be, I would need to have a higher height. So I could go to the height 3 or I could go to the height of 2. I guess I go to the lower of the two heights. Is that right? Or do I go to one that's closer in base? I think I go to the lower height. I go to 2. 120. 1 goes all the way to the other 1. Then the pointer goes to 2. The 2 pointer needs to go up. Pointer needs to go to a higher amount for each end. So it has to go to the 3 and has to go to the 2. Because if the amount is the same, then the tank doesn't, there's no way the tank improves. So because it's 1 here, the height of the tank is currently 1, so the height of the tank has to be increased. So it has to go to 2 and has to go to 3. Okay. And then 2 compares with the 2 goes to 3, and that's like times 17. So it's 34. The height being 2. And so this pointer now goes to 3. And now the height goes to 3 goes, so it's 3 times 16. It's 48. And now the height needs to be 4 or higher than 3, so it has to go to 4 here and has to go to 8 here. So 4 goes to 8, and that gives you height of 4. 3 times 14, 4 times 14 is 42. 42. I think this is n of n if I try to do this kind of leapfrogging calculation with increasing heights. Heights can be up to 10 to the 4th. Okay. So let's say, I'm going to say monotonic increasing stack for left side of tank. This is called a tank rate. I'm just going to consider this a water tank. Let's say left is going to be for every index, actually, for every height in, I think I can use a for each loop here. Maybe I can actually set it up so that it starts with 0. I don't think the tank actually has 0 as a possible, no, it does. Maybe I need to set up so it's -1. So I want to have a dummy value here. I guess the dummy value could be 0, 0. Or 0, -1, something like that. So for every, I actually do need to know the index. N is the length of height. H is the height at this index. If this height is bigger than the left side's, the biggest height so far, then left appends this tuple that is height index, and then have a monotonic decreasing stack for the right side of the tank. And this one I think should be, I mean I could do another for loop. Yeah, I guess I could do a for loop. A backwards loop from the right side index. Or I could do wonder, or I could do some stuff with popping if I go left to right in indices. But actually if I do a monotonic decreasing, I guess you never actually pop if you just do it in reverse order from rightmost index to the leftmost to zero index. Just never pop if you do that kind of traversal. Interesting. I think that's correct. Index in range. It's okay, yeah. So I in range n minus 1 to 0. Height is height of this index. I think there should also be like 0 index n maybe. If the height is bigger than the last height that was added to the stack, right append this height index combination. Let's go ahead and print out the left side and the right side. Okay, so this should say 1, then 8, and that's it. And then decreasing, it should be taking 7, then 8, 7, then 8. And this side should be 1, 2, 3,000. And this side should be 9,000. Okay. And so now I think it's going to be 2 pointers. 2 pointers for determining best tank. So say LP is left pointer, starts at index 1. Right pointer also starts index 1 of the right side. Left pointer equals right pointer equals 1. Maybe I can do a dummy thing at the very end so that I don't have to check that the pointer is at the last. Maybe. So I can do something like answer equals 0. Height is equal to, I guess currently the height's 0. So I'll do a while true loop here. So first step is I'm going to actually I'll start with the left pointer and right pointer being at 0. So while I need to move the pointers away from the current height. So if LP is less than the length of the left side and the height of that left side at LP, the height of that is equal to the current height, then LP increments. If the right pointer is less than the length of the right side and right pointer at the right side of this pointer height is equal to the current height, then right pointer increments. Okay, and now the current height is the minimum of the two heights. Left at the left pointer, right at the right pointer. And then the tank is going to be the height times however far those left side and right side are. So it'd be left pointer, index 1, right at the right pointer, index 1. So that's the total base. And then while true. So this thing needs to break if the left point and the right pointer is at the end. If left pointer when does this thing break? Increments, 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 increments. I think it breaks right here if the left pointer is equal to the length of left minus 1 and the right pointer equals the length of right minus 1. Or I can make a dummy that has infinity, infinity at the end of the left pointer and right pointer, and then if either of them hits infinity, yeah, maybe that's the play. So left dot append tuple that is infinity, infinity, right dot append tuple that is infinity, infinity. So in that case, I don't need to check this or this. But I do need to check if the height is infinity. Okay. Did I not append a tuple? Oh, is this not height times not supported? Is the answer? Something wrong with tuples here? No, that's right. Right pointer, right at right pointer at 1 should give me the index. Left at left pointer at 1. Is my parenthesization here wrong? Should give me a single base. That's the closing parentheses for max. Okay. Guess maybe I mistyped the parenthesization. Oh boy. Didn't give me. Oh, oops. Oh, that didn't go to the. Yeah, this is still gonna give me an error, isn't it? Because. So I'm comparing an integer to a tuple. Okay. Right at the right pointer at 1 minus left at the left pointer at 1. Let's just go delete this. What is it gonna give me for the interesting. 1, 0. The base is 1 and the height is 0. Really? If the height at the right pointer this is just really surprising that this thing is giving me this currently. Left at the left pointer, 0 equals height. Left pointer should become 1. Right pointer should become 1. Height, oh my gosh, this is not correct. It's the minimum of this thing bracket 0. Fuck. It's a disappointing mistake. Okay, this should be right. Height times base. Okay. Oh my god. Well, that's cool. Oh. Okay. Back to bookend stacks to prevent indices from going out of bounds. Okay, I guess this should be answer equals height equals 0. Left pointer and right pointer. So increase height or increase the pointer on the left side if it's the same as the current height. Increase the pointer on the right side if it's the current height. Determine what the current height is. If the current height is infinity, then that means that you've gone too far. Base is the difference between where those heights are, and the answer is equal to the maximum. Okay. Well, I don't remember ever doing something like this, and I probably will forget it shortly. But this is the keynote. If I maintain a monotonic increasing stack of heights, the left side is within that set, or within that stack. Because a height that is lower would just want to use a height that is bigger before it. Okay, so summary is going to be C keynote, create 2 stacks for the monotonic increasing heights and decreasing heights. Can use a backwards can use backwards traversal of indices to get the monotonic decreasing stack. You can also do it in increasing order, but you'd have to pop stuff off the stack if that's the case. And then to determine the best tank, so combination of left right sides. Also stacks should incorporate or include the info about the position of those heights. So used a tuple of height and kind of base position in stacks rather than just heights. Determine best tank, combination of right side and left side. Use 2-pointer technique with a current height variable. Answer is initially 0. Height is initially 0. While left pointer and right pointer are at tuples where height matches. Increment or move pointer along. Determine the height of current tank described by left pointer and right pointer as the min of the heights at those pointers. Determine the base as the difference of the base positions at those pointers. Update the answer based on the area calculated. Update the height. Use some way to break if at the end of the stacks pointers reach the end. Return the maximum answer found. And that's, so this is the current height. Move the pointers along if they're at the current height. So since I initially made it so that there's a dummy height of 0, it's going to move to the first non-zero height, which should be at index 1 at each stack. And then determine the height of the tank based on the two heights of those left side and right side. Base is the difference in the positions of those heights. And then area is the base times height, and that can update the answer if it's bigger. And then loops breaks when it's infinity height, because there's a dummy infinity tuple at the end of both stacks. Time complexity is going to be O of n in order to create the monotonic stacks, and also O of n to do the two-pointer. Note that the pointers are always increasing, doing basically one pass. Is it doing one pass? Yeah. Each pass is moving it up one, moving one of the pointers up one at least once. There can be only most n pointers or n values to those stacks. So yeah. Pointers, the pointer or while loop will always move a pointer, at least one pointer, up one each time, and the total movement of pointers is at most n. Constant work in the rest of those loops. There's just constant like appending or calculation of areas. Space complexity, this is O of n to create the stacks that can have at most n tuples, and